So for everyone that's in the call at the moment, welcome to today's Zoom presentation about the sinking, salvaging and scrapping of the Costa Concordia. Today's presentation will be delivered by Noel Phelan, and in the absence of David Michael, I will be hosting the presentation. My name is Lloyd Skinner and I'm a midshipman gap year currently working at the Historical Society. So for everyone in the call, there'll be a chance to ask questions to Noel at the end. And I'll hand over to Noel now to begin his presentation. Thanks, Noel.
Good morning, everyone. Welcome to our last presentation for 2020. So without more ado, let's talk about the loss, salvage and scrapping of the Costa Concordia. This is probably what you saw on the television or in a newspaper on the front page of the newspaper, a very large liner over 60, 70 degrees on its side on rocks at the east side of the island of Giglio. The material, a lot of the material for this presentation is based on this book. The author is Captain John Dickenberg. That man on the cover is not him. That's Captain Edward John Smith of the Titanic. And you can see the heading there, Crisis in Leadership at Sea, in whom we trust. So what John Dickenberg has done for 100 years, from Titanic to Costa Concordia, has looked at 14 crises at sea. And included in those are the ones that may be interesting. The USS Indianapolis, which carried the atomic bomb and was torpedoed on its way back. The Graf Spee, of course, the Battle of the River Plate, the Titanic itself, the Hood and the Bismarck. Not many of these people lived. The Captain Hans Langdorf of the Graf Spee committed suicide, as did Captain Charles McVeigh of the Indianapolis, and of course the captains of the Hood and the Bismarck went down with their ships. So that's what it's based on. It's a great read if you're interested in what happened at sea. But what he focuses on is as much as what the ship, what happened to the ship, the background of the captains and how that background influenced the decisions they made. A good example is the Graf Spee. Hans Langdorf was brought up in a very Christian environment, and he decided to scuttle his ship because he did not want, he believed if he left and went into a battle again, a lot more of his crew would be killed. So really interesting read. So this story is as much about the ship as the captain, Francesco Schettino. This is what we're going to have a look at: the ship, the captain, shipping industry at this time, the timeline of what happened. We'll go on the bridge and talk about what happened there. Then the rescue of, there's over 4,000 people to be rescued. No single thing leads to an accident like this, an event like this. There is a chain of events that led to it. The changes that the industry made after this, and of course there was an inquiry and some report findings and some recommendations. Then we'll look at how it was salvaged. This is a brilliant piece of engineering, and of course the scrapping, and there is a little bit of an epilogue, what happened after. Right, here's the Costa safety record. 2005, fire on Costa Classica. 2006, gangway collapse, doesn't sound too bad. 2008, collision with another ship. 2008, the Costa Concordia itself crashes into a dock. 2009, Costa Romantica is on fire. 2010, the Carnival Miracle, it crashes into a pier. Another crash into a pier. 2010, collision with a ship. 2010, on fire. And then the one that we're going to look at, Costa Concordia accident. I hope you are prepared to buy a ticket to go on this particular cruise line. So let's have a look at the ship. It's owned by Carnival. Carnival owns nearly half of the cruise ships in the world, and it cost 900 million. Remember that number, it becomes very important. It's in service in July 2006. And these are interesting numbers to remember. Think 100,000 tons, 3,000 passengers, length of 3 football fields, 290 meters, draft. And however, the large cruise ships that are available today, the Symphony of the Seas is twice that with over 6,000 passengers. So these things have grown to be enormous in size. Here we are. Here's the Costa Concordia. Beautiful looking ship, built in Italy. Here it is at sea. And here's the cruise they're going on. It's a 7-day cruise around those particular ports. And the red star is how far they got. They only got a couple of hours having left Rome. So they didn't get too far on the cruise. Now, if I say to you, all right, what ships, what are the name of ships at the front of your mind, the ones that you can immediately remember? Of course, here's the Titanic. Here's a scale model of the Titanic and the Costa Concordia. You can see the Costa Concordia is significantly different. You can see the bow thrusters down here. It doesn't have azipods, rotating propellers with no rudders. It has 2 shafts. And here's another ship, which I'm sure you'll remember for some time. This one's called the Ruby Princess. Now, why is it called Concordia? It's about the countries in the European area. So it's completed in 2005. However, the standards, things are changing so rapidly. The standards are old. To bring in a standard, you need the thing to be in place, the standard committees to approve it. Often it takes forever. There was a new set of standards in 2010. Quite fast, 20 knots. It's got 4 diesel engines and 2 electric motors that drive the propellers. 3,000 passengers, as I mentioned, 1,000 crew, so that's 4,000 all up, and it's got 13 public decks. These ships have just increased the number of decks, and of course the windage is significant when you've got that amount of superstructure, large superstructure above the waterline. And it was 13th of January 2012 when it was sunk. All right, here's a quick lesson in Italian. So these are the names of the decks to go with the name Concordia. The one I like here is the one I can easily remember, is this one here, 12 Austria, where in Italian it's the same as English, and Polonia, Poland. It's below those 13 decks. It's got a bulkhead deck, and below that, of course, is all the machinery in 3 decks. It's got 16 watertight compartments, which just happens to be the same as the Titanic. And it's got 2 engine compartments and 1 motor compartment, the electric motors that drive the propellers. And all of the electrical switchboards are down there to control the whole all the electric circuits for the ship. You can imagine just how complex that is. And of course, the pumps are down here. Should there be ingress of water, the bilge pumps, etc., and all the equipment for damage control. And if any 2 of those 16 compartments flood, the ship is still okay. The captain, he's 52 years old at this point in time. Here's an interesting one, how to get a job. His mother was the ship owner's daughter. Sailed with ferries and tankers, but no experience with cruise liners. And he takes the job up in 2016, married with a family. And when he's interviewed by the Costa president, amongst the notes from the interview is 2 words which have never really been explained, character issues. All right, during the inquiry, of course, all of his officers were interviewed, interrogated, and typically the words that he described Schettino as arrogant, too exuberant, braggart, show off, inflexible authority, a very old-fashioned captain, do as I say, don't ask me questions, and don't offer advice. I won't take any of it anyway. So interesting personality. Let's have a look from his point of view, the timeline. January the 13th, it strikes the rock and grounds. The next day he's detained. We'll see in the presentation why he's detained. Then the passengers get compensation for the loss of the voyage and their personal possessions. Then a year later, Costa's fined. The ship is in a very pristine maritime environment, very important to the economy of the island of Giglio. And then a trial of all involved. They're all found guilty. and Schettino's given 16 years in prison. Here he is here, Captain Schettino. What's happening in the industry at this time? There's really rapid technology development, not only ASIPods and things like that, but all of the electronics on the bridge. And of course, it's very hard to get people with experience to do this. And a lot of the people just don't have any previous experience, so they just believe in the technology. They don't have the experience to test it, and there's no questioning or logic. It's just do what the technology is telling you to do. You may be interested in, there was a couple of US Navy ships got into collisions 2 or 3 years ago. The technology, they just thought the technology was doing something and it was doing something different. That's how the collisions happened. And it was just a confidence. We'll be right with all this stuff. What could possibly go wrong? And of course, the regulations with this rapid pace of technology aren't catching up. And at this point in time, you wouldn't want the passengers to have the inconvenience of going to a muster station and finding out where their lifeboat is. So you can go for the first day at sea without any of the passengers knowing their muster station or anything about lifeboat drills. And there is a bit of an issue in an emergency. Out of that total crew of over 1,000, most come from countries, third world countries, cheap wages, and there's 40 nationalities on board. Some of them can speak broken English. So in an emergency, getting the crew to do things is going to be a bit difficult. So 7 o'clock leaves Rome. 3 hours later, I'll just generalize these times rather than be specific. Then at 10 o'clock, it loses power. It continues under its own momentum. The breeze and the current turn it around, and it comes back and grounds at around 11. It's nearly midnight before the order is given to abandon ship, and the rescue takes another 4 hours to get everyone off the ship, and 32 passengers are unaccounted for, and after a while they can only find 30 bodies. So there's 2 bodies still on board the ship. This is what happens on the bridge. I'll just show you a couple of shots of bridges. Here's, if you like, a bridge before all the electronics. You can see there's a great lookout being kept, not a lot of television screens. Here's what a modern bridge looks like. Televisions, computer screens everywhere. Here's a modern ship, and you can see just the number of computer screens, but notice the officer in charge there is not relying on all that stuff. He's clearly in a harbor. He's keeping a very good lookout with a pair of binoculars as well as looking at all those screens. On the bridge, of course, we've got the steering, controlling the rudder, the engine controls, speed, thruster controls, compasses and charts, and we've got a chart plotter, if you like, and an electronic chart, and a computer navigation system, radar, a fathometer to tell us the water that we're in, and the AIS system, which is going to tell us where every ship is around us, the course it's on, the speed it is, and the sort of ship it is. So Schettino instructs the navigator. We're going to do a course deviation here. We're going to do some touristic navigation. Touristic navigation, which had been done before, mainly in daytime, not at night, is to go close to a port or an island and show the ship off to the people and also allow the people on board to see an island. This is not quite true. There's no communication of the change to the other officers. There's only 2 people know that this is going to happen. The company is not advised that it's going to divert from its normal route, and it really is Schettino's salute. A previous captain was his mentor and is now retired on the island, so he's going to come in close, blow the horn, get on his mobile phone, and do what's generally called a salute to his mentor. The navigator uses a small scale chart, and the course is entered into the system. There's, as I mentioned before, no one else knows what happens. Francesco then goes to dinner. The ship has now started to change course. And the next thing after dinner, he comes back onto the bridge with the maitre d' who lived on the island, and a woman accompanying him. And he gets on his mobile phone, they're approaching the island, and calls his mentor. He now takes manual control of the ship. Here's a diagram which illustrates what happens. You can see up here, this is the deviation, a significant deviation from the normal course of the ship. And this large diagram just shows what happens. It hits the rock here, continues under its own momentum until it stops here. It's turned around and then pushed back onto rocks here. You can see it's just north of the port of Giglio. Here's the lady during the inquiry. She's a Moldovan dancer. She was asked lots of questions, and when threatened with a jail sentence, she finally, and the question that was asked, where were you planning to sleep tonight? You have not been allocated a cabin. She had to admit she was Schettino's lover. So now Schettino decides to go even closer, halves the distance from the shore. The officers are just standing there. He's showing off to his lady. We'll just leave him to it. Now to manual control, increases the speed to make things look a bit spectacular. And very quickly off the port bow, sights broken water. He's, I race a yacht. I know what you have to do when you've got to avoid something. If you're approaching a buoy and it's not going to happen, the breeze is not going to let you get past it. You at best will hit it. You've only got one option. That's to go hard to starboard, to bring the bow, rotate the boat, bring the bow away, and then at a point where the buoy is halfway along, go hard to port. Now, Schettino screams at the helm. He's not steering it himself. He's got an Indonesian helmsman. He's got the helm hard turn to starboard, and then it's a hard turn to port. The Indonesian helmsman doesn't do the hard turn to port. He looks at Schettino with that look in his face which says, "Make up your bloody mind." And he's got no idea what's going on. And the seconds, precious seconds where all this happens contributes to the collision. Immediately, the order's given to close the watertight doors. 3 key compartments start to flood. You may recall the ship's only okay with 2 flooded. The engineering crew are sitting down there thinking they're all out at sea. So they're taken by surprise. What happens? Lights go out. The switchboard, which is down there, salt water and electricity doesn't work too well. And the emergency power system also fails. It only works for a short time. So communication's now reduced, and they're now on emergency battery power. The ship with taking water lists to port, and Schettino goes into absolute shock. He's denying that anything's happened, and he's trying to ignore the situation. And then he starts lying about the situation. He's telling people, look, we've just got a slight electrical problem. Just relax, it'll all be fixed shortly. And he's withholding information from his other officers. Now, 3 compartments are flooded, 2 more are flooding. At this point in time, he should have issued a mayday. I did marine rescue for a few years. This is what it sounds like. Mayday, 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 mayday. This is Costa Concordia, Costa Concordia, this is Costa Concordia. As soon as you get a reply, you report the vessel, it's a cruise liner, 4,000 people need to be rescued, and your location. He doesn't do this, which means if he did do it, there'd be red buttons pressed everywhere, and as marine law dictates, everyone needs to come to help. The helicopters that finally try to find the ship are out where it normally, in its normal course, so it takes quite a while for people to realize where the ship is. Once again, electrical problem, so everything's okay. And the officers there stand while he's doing all of this. He's the officer, he's the captain on the bridge. This is what he wants to do. They choose not to intervene, even when he's telling obvious lies. And now some of the passengers are concerned for safety. They realize something has happened and they start to don life jackets. The Costa fleet crisis, all of these cruise lines have a crisis center if something happens. It's called, and Schettino says we hit something, certainly did. And then in questioning, just denies what's happened. And the person at the crisis center doesn't do a very good job. It does a very poor job of trying to question Schettino. And of course, he should have realized that there's something funny here and asked to talk to one of the other officers. But he continued to talk to Schettino and finally said to him, look, drop your anchors and assess the damage. Now Marine Rescue gets involved. There are people on the ship calling ashore and life jackets are issued. The water's now in the passenger spaces, so they know there's things aren't right. And the ship turns around and comes back and is blown, as we saw in the diagram. It now starts to list to starboard. The huge windage takes an effect on the ship now. They request a tug, none is anywhere nearby. Now Marine Rescue gets involved. A general alarm to get people out to their muster station. Unfortunately, they don't know where to go, and they just board the nearest lifeboat. So things are a bit chaotic. The anchors are dropped, but without a proper procedure, they fail to hold. Now the order is given to abandon ship. The ship grounds, and now it has a pivot point. The center of gravity, of course, changes once it's got a pivot point, so it's going to list and it's going to capsize, and it finishes up 60, 70 degrees. And Schettino claims he slipped down that sloping deck and fell into a lifeboat, and he leaves the ship. Now the passengers, with no one in control, organizing anything, they have to fend for themselves. Launching the lifeboats is extraordinarily difficult with this list. The starboard ones swing way out from the ship and are very difficult to anyone to board. And the port ones are stuck to the ship and really difficult to launch. And to move around on the deck with a 70 degrees list, and then water starts coming into the spaces. The Coast Guard now knows they've got a real problem. They are diverting rescue boats. The helicopters are scrambled, Air Force, and some decide with no rescue in sight, they'll dive into the water and swim. A lot of them don't make it. And then when a lifeboat comes into the port of Giglio, Schettino is discovered in it. And you may have heard some of the dialogue between the Coast Guard and Schettino with the captain of the Coast Guard ordering him back to the ship. There are hundreds of people still on the ship, and by law, he is required to stay on that ship till all of the passengers are safely off. He just leaves and goes to a hotel. Here's what it looks like. It's a 70-ton rock with tore through the hull. This rope ladder here becomes very important in the escape story, the rescue. Another shot of the rock. Interesting, the stabilizer was out and it must have just missed the rock. This is the site when you woke up in the morning from the island of Giglio. This is the site that met you. And of course, we had a look at this one before, just another shot. Right, so this is when the ship is righted. It's written off. Divers that went down to have a look at it is sitting on two pinnacles of rock, and you can see the 100,000 tons with storms over the time. It's just grinding itself to pieces. Another shot of the enormous damage, the side that's on the rock. Close up of the rock, and that rope that's what it's used for. It's never intended for that. We'll see in the next slide what it's intended for. It's intended for a pilot to climb on board and leave the ship. You can just imagine being on that rope. One person, they of course think about the age of the people. One person up the top of that rope slips. The rest are going to go cascading down. Here's what it's really used for. I went out on a pilot boat to put together a presentation on the history of pilot boats. Here's the rope ladder here, but these two ropes up here are what are used in the handhold. That's only meant for the pilot's feet. He's got two other points to hold on for his own safety. Here's a shot of the one of the rescue helicopters taking people off. Why capsize to starboard? Most of these ships have cross flooding. Once the compartments on the port side are complete with water, water will flood across to try to keep the ship upright. But it's the breeze that turns it round and lifts it to starboard, and it grounds. Right, what were the chain of events that led to this? The navigator used a small-scale chart. If he'd used a large-scale chart, I think he might have been a little bit more careful with his course. And turning off the computer navigation system and going to manual control wasn't... There are alarm systems connected to the computer navigation system, which when turned off, those alarms are turned off as well. And of course, the lack of communication and the communication issue with the helmsman, the design of the ship itself, particularly all of the stuff below, the switchboards, and of course, nobody in command. Once Chetino went into shock, nobody stepped forward. The training of the crew, they weren't trained for the lifeboats, and of course, the communication with the crew. Very quickly, the Cruise Line Association reacts. Now you can't leave port without people knowing the muster station and lifeboat passage planning. You can't, everyone on the bridge, all the officers need to be involved in if there's a deviation. Bridge access is limited, no more bringing your girlfriend up on the bridge, and additional life jackets so people don't have to go back to their cabin to get their life jackets. And then in this particular case, the ship did not know the nationality of the passengers, so they didn't know what languages to communicate in to ensure all the passengers knew what was happening. And some emergency instruction standards come into place. More changes now, lifeboat practice, so the crew do know just how to launch the lifeboats. And once more teamwork on the bridge, more locations of life jackets so that people, wherever they are, can easily grab a life jacket. And the report, the inquiry, the report from the inquiry, scathing of the bridge management, as you could expect, praise the engineering crew who did everything they possibly could down in the engine compartments and the switchboards to try to do something, however unsuccessful. No monitoring, failed to bring attention to the danger. The officers just didn't do anything. And of course, then chaos happened. And there were procedures to handle situations like this. The crew didn't really know their duty and in some cases ignored it to get the muster list out. And it turned out the officers didn't have a great understanding of just technically how the ship worked. They didn't put a damage control team in, which normally, as you would remember from Titanic, goes and assesses the damage and reports, and then the decisions are made, how do we minimize this as best we can. And the final words were failed in most aspects of duty for the captain and officers. 5 people are found guilty, manslaughter, negligence, wrecking the ship. The crisis director, who didn't do a very good job of interrogating and finding out what was really happening here. The person in charge of all the crew, the first officer who should have stepped forward, the helmsman, the third officer. So all of the officers on the bridge are found guilty, and they plea bargain. plead guilty, and they get 2 years, but they don't go to jail. All right, so this is what the report, the inquiry report recommends. People banned from the bridge. The double hull, there is a double bottom in most of these ships. Extend that up, so if this something like this happens again, more redundancy, particularly for the switchboards and emergency power, and review the launching of lifeboats. Can a system be designed where when a ship lists significantly, the lifeboats can still be launched? Now we start with the salvage. The ship's on the rock there. The first thing, it's only been 3 hours into a voyage, so you can imagine the enormous amount of fuel and food, etc., on board for that 7-day cruise. And due to all that damage, it's a total loss. In 2013, it's brought up to vertical. That cost, remember, it cost $900 million to build. How would you like to have an insurance policy where your excess is $30 million? And a year later, 2 years later, they start to refloat it, and the cost is now $1.5 billion. Towing and scrapping another 150 plus. The final cost is $2 billion for a ship that cost $900 million to build. So, as I mentioned before, it's a special protected marine area, important to the economy of the island. And there's, for example, there's 200 joint fan mussels, which are a particular form of mussel. They're removed to protect them from all the work that's going to come on. And there's thousands of tons of heavy fuel oil, and you just can't take something like this off the ship. It will change its position on the rocks. It may slide down. So you've got to do it very carefully. Pump the oil, suck the oil out, and allow water to come in to keep the boat, to keep the ship as stable as it can be. However, with all of the storms that are happening, it is moving slightly. It's on a slope. And as we saw, it's collapsing under its own weight. And when the divers go in to try to retrieve the body, there is enormous debris inside. There's furniture floating. We'll have a look at a couple of slides of that. And finally, they have to use explosive to blast holes in the hull to go in and retrieve bodies. By the way, if you're out cruising here, that beautiful glass lift which takes you up many stories, think it twice about getting in it. A lot of the people were in there when the power failed and were drowned. Here's the fan mussels that they moved to protect it. Here's a couple of shots of inside the ship. You can imagine it being a diver going in here, all of this stuff floating, trying to find bodies and assess the damage. Here's the casino. It looks like somebody got the money out of the poker machines before it finally went down. But just all the stuff from the ceiling, there's just debris and stuff everywhere here. Now, how do ships get salvaged? Here we get into the brilliant engineering bit. Well, the Kursk had its front cut off it this way. And here's what you do. Here's the car carrier trickler. Its car carriers are notorious for capsizing if they have a problem. And here it is on its side. It's only in 35 meters of water. So what you do is you go, all right, well, we've got lifting gear. How heavy can that lifting gear go? All right, well, we need to cut this ship up into as many pieces as necessary so that each piece we can lift up. So how do we do the cutting? You'll see the two platforms either side. You can have barges or whatever either side. And here is a wire rope, a steel rope, and it's embedded with diamonds or materials that are as hard as diamond. So you just make a hole under the ship, drill a hole under the ship, run this cutting wire, and it's just a giant hacksaw. There's only one problem. You have to do it. You cannot stop. Those of you familiar with doing hacksawing, if you stop and it jams, you normally can't get it started again. So that's if you like, the standard technique for salvaging a ship this size. Never been done before with a ship the size of the Costa Concordia. This is a shot of the tricolor. That's the engine room. You can see the engines. It's all just steel after all. You can just cut through it, propeller shaft, the whole lot. And the next bit you do is pull the portion up, a couple 100 tons worth, and load that on a huge barge or barges and take it to be scrapped. Now, there's a problem, or you can bring one of these huge lifting mechanisms over and retrieve it. Now, there's a bit of a problem here. You can imagine trying to cut the Costa Concordia up. The stuff that's in all those passenger cabins is going to come out. Cleaning up the debris is just going to be really difficult, and we still have bodies there. So this standard way of doing it, or the normal way, is not suitable, and it's just going to result in an enormous problem, and we've still got the bodies. So where do we go? When was the last time huge ships that were on their side or even upside down were salvaged? So you start to think about the German Grand Fleet that was scuttled at Scapa Flow by the Germans. But more importantly, they go back to Pearl Harbor, the USS battleships. A lot of the US battleships were righted, and some were brought back into service. And it's a technique centuries old called power buckling, where you put rope round with a mechanical advantage. The number of ropes that you use give you more power, and you can rotate something using this principle. So here we are in Pearl Harbor. That's the battleship Oklahoma. It's nearly upside down. It's a shipping hazard. It's in the main channel. It has to be removed. It's been hit by 4 torpedoes and a couple of bombs, so it's seriously damaged. So here we go. All that equipment, the hull of the ship is below all of these structures here. Just look at the number of wires and the number of pulleys, and you can figure out the mechanical advantage here. The mechanical advantage is enormous. They have something like 100 of these winches pulling, and on a good day, it all works. Here's the Oklahoma coming up. Here it is 90 degrees. Here it is 100 degrees. It's now sitting on the bottom. All you need to do is patch the holes up, pump the water out, and you've got it into the floating dock. Now, unfortunately, it's damaged so badly, it can't be brought back into service, but a lot of them were. So this is what we're going to do with the Costa Concordia. Now, you may look at this and think, gee, this isn't big. Now, remember, this ship is 3 football fields long and over 100,000 tons. Goodness knows what it weighs with all that water in it. So we're going to drill down into the rock here, and we're going to put piles. Divers have to go down with pneumatic hammers to do this. Now, think about this. This is the steel here is something like the Sydney Harbour Bridge. And of course, it has to be perfectly in alignment, just like when a ship is docked. When you're going to roll it onto this, it's got to be set up so that the ship isn't damaged. So the shape of the hull is important. So the engineering here is just incredible. And to support the ship, 2,000 grout bags are going to be put here. They're used just like pillar slips. The grout is pumped in. Once it's all the right shape and the right level, it's going to set. And here we've got sponsons here. These sponsons can either be full of water or air. If they're full of water and water's pumped into them, the weight of that water is going to tend to rotate the ship, but the ship is going to be rotated by cables underneath here, and these are things called strand jacks, hydraulic jacks. So there's going to be a huge number of cables attached to the ship with the sponsons. Remember how many decks there are? These sponsons are 13 floors high of a building. Engineering is absolutely enormous. Here's what a strand jack looks like. It just pulls that cable through it, holds it, goes back down, and gives it, pulls it another length. Enormous power. So this is what's going to happen. The sponsons are going to be attached, and all of these cables here, etc. Then the ship is going to be rolled upright onto the frame below, Now sponsons are going to be attached to the port side, and then the water in the sponson is going to be pumped out and the ship will float. Here it is on its side with the sponsons being attached. You can see the enormous number of strand jacks over here with all the cables attached to it. Another shot of showing all of the sponsons on the side, all the cables and strand jacks. And they then discover that they think the bow will detach when they do this. It's unsupported in this way, and they decide to put this structure here around the bow. This is huge. Look at the ships and tugs. This is massive engineering. And here they're going to put it out here. They are here. It's like a huge collar under the bow, so that as it rolls, it's supported and the bow doesn't break off. Here it is. It's now upright. It's been rolled upright, sitting on the frame. The water's been pumped out now, so here it is. It's floating. The next job is to tow. 2 years later, it's going to be towed to Genoa. It's not far away to be scrapped. And it's going to take 4 days at 2 knots. Nobody knows what's going to happen here, the real condition, the stress. And they have a fleet of 14 ships around it, firefighting ships. And it eventually is moored at a seawall at Genoa. Here it is. That little tug out the front isn't towing it. You'll see some very heavy tow wires out the side. It's probably helping to steer it. Here it is under tow. Now, what do you do with a 70-ton rock? Probably the best thing to do with it is put a plaque on it for the 32 people that have died and lower it back where it belongs. We're now in May 2015. It moves to the dock. Upper decks are removed, then the sponsons are removed, then it goes to a dry dock. And it's expected to be completed in 2017. That's 5 years after the accident. Here it is alongside in Genoa. You can see the funnels removed and the decks are starting to be removed. You're not too fussy how you scrap a ship. You can see here, you just grab, with hydraulics, you just grab a huge bit of the ship and put it on the dock for it to be removed away. Sponsons are being removed. Here it is in dry dock. You can imagine what has settled down into the lower parts of this ship. The work is hazardous, dangerous, and extremely poisonous. So it's all here on a particular day, and then the next day it's not. And the only explanation, this ship is controversial right to its end. What is left here, obviously the cost of scrapping it was going to be much greater than the steel and the material obtained. It's been towed out to sea, out into international waters and sunk. Now, when things like this happen, there's always somebody comes to the aid of the person that's been suffered the most here. And Schettino, so there is a bit of an uprising here, well, look, Schettino, poor man, suffered shock. 16 years is a bit excessive. We really should have had double hulls. And the mafia who kill people in Italy and Sicily get less than 16 years. That's a bit tough. And the investigation wasn't carried out. But they do have a point here. He's one of the first people to be really well tried by the social media and press. The front page of the press has got a photo of him with the headlines, Captain Coward, and things like that. And there's a huge change in the relationship between the company and the captain. And of course, they're all flying flags of convenience to save costs and enable to hire crew at lower rates. And of course, when something happens, the officers are easy targets. But today, there is, just like most things can be remote control, there are fleet operation centers that can have duplicate instruments. They know what the ship's doing, et cetera, et cetera. and in some circumstances can take control of the ship. You probably all remember MH370. It took some time for Rolls-Royce to come up with every hour the engines on our planes transmit the performance data to our headquarters so that we know what to do next in maintenance. So there's a lot of things happening using satellites today. And of course, once you have this situation, you really don't have the captain in complete control of the ship. He may be getting on advice on what to do. He may even have somebody change something on the ship for him. So that's the story of the Costa Concordia. Hope you've enjoyed that.
Noel, what was the effort to find the two missing people from the collision, from the crash?
I should have mentioned that. One was found when they salvaged the vessel.
Yep.
And the last one was found when they were scrapping it.
Okay.
All right, we're done. I think, Lloyd, thank you very much, Lloyd.
Well, we'll conclude the presentation there. Thanks a lot, Noel, for that presentation. Very comprehensive and interesting.